Oh, I haven't downloaded the slides.
What's that?
I haven't downloaded the slides. How much time do we have?
Minus 15 seconds.
Minus 15 seconds. Okay. I was busy exploding at somebody instead of doing break things. All right. All right. Tell you what, if you project your slides, then I can do the usual thing of downloading the slides and.
You know, it's basically the same thing. This is just bigger. This is a bigger version.
All right. Looks like we don't have critical mass assembled quite yet either.
We'll be getting started in just 1 minute. Okay. Sure.
I did check, and yes, I do have a login for tools.
You want me to get started?
Let
me just pass my solutions.
Nothing left when I showed it.
All right, I'm going to get started.
Yeah.
Okay, we're going to get started. Sorry about that. The last room, if I didn't lean in, it was a little quiet. So welcome to Berlin and to DETNET. I'm Lou Berger. Pat Taylor is my co-chair. And we also have Yoni here, who's our secretary. He's volunteered to be taking some notes in Etherpad, and we invite everyone else to join in collaborative note-taking. It's helpful because it allows people to participate as well as to take notes, and it also gives you an opportunity to make sure that your comments are captured accurately. If you're not sure how to get there, you can find it on the tools page, tools.ietf.com. Look for the DETNET working group and agenda, and you'll see Etherpad 96. And we also have Jabber. I will get on the room in just one moment, so apologize if anyone's out there. That's really important to take as a channel for people, remote people, to make comments. We have the IETF Note Well. It's still early enough in the week that some may not be familiar with it. It basically says that anything you say here publicly becomes part of the record. And we are audio streaming, recording audio, as well as video streaming and recording video. We've already gone over Jabber. There's just the reason it's on this slide is we don't forget about it. And the agenda is both already in the Etherpad and available at the IETF websites. There are blue sheets going around. Please sign it. It's important for setting room size. The funny thing is I just came from a meeting that could have used this room and we could have used theirs, but whatever. And I'd like to run through document status briefly. So we have a use cases that has been updated. We're going to hear about that next. We have a newly adopted working group draft, and we have 2 drafts which are not yet working group drafts, but we expect them to, based on the discussions in this meeting and the sense of this room, as well as then taking it to the list, we expect that these will rapidly become working group documents. Right now, and as you saw on the list, the biggest impediment, at least on the architecture document, has been getting a consistent view on the terminology. We wanted to get that settled before having a working group document and possibly indicating to people that we had agreed on terminology when in fact we hadn't. So we'll be talking about terminology today as well. We've already talked about the agenda. And please use the list. One of the things that's been going on is that there's been a lot of design team discussions, and those design team discussions have resulted in updated documents. As we move those documents from individual documents to working group documents, we expect that the conversation to shift to be an author's conversation, to be a more inclusive whole working group document, utilizing lists and informal calls that the design team members will probably continue to have, but then be open to whoever else would like to participate. We do have an IPR disclosure process. It's just, maybe it's familiar, but basically before we do adoption or anything, any major step in the process, we do poll for IPR. Comments and questions before we go on to the use case?
I noticed the link for the, just to know, it looks like the link for the DETNETs, the last topic, the information flow model slides, is wrong. For some reason, the actual file is 7. Yeah,
it shows up in both.
Oh, it shows up in both. It just doesn't show up in data tracker as both. Okay.
Right. Yeah, for some reason, 6 disappeared, and so we have the same presentation available through 2 sets of links. That's all.
Oh, okay.
Do we want to plug into yours, or do you want me to do it?
I'm gonna plug. I'm set to run it now.
Okay. So we're going to shift to use case,
And that way you can watch Jabber.
yeah, and that way I can get on Jabber. Who's giving use case? Oh, Ethan, are you out there? Here he comes into the queue. And don't I have to hit I hit red, right?
Okay.
Welcome, Ethan. You look great, and we hear you fine. So thanks
Okay.
for our first, by the way, our first remote presentation in DETNET.
I'm Ethan Grossman from Dolby Laboratories, and this is the use cases draft update. The use cases draft, as you all know, is comprised of a number of different use cases that were brought together into one draft and adopted by the working group, and this is that draft. There's a lot of material here, and we don't have time to cover it today. We have only 15 minutes, so basically I'm going to breeze through it quite rapidly. Next slide, please. See, I can't see your slides. I have my copy of slides up, so I'm just going to assume when I say next slide that that's gone through. So this is the contents of this presentation. Most of this has been gone over at previous use case presentations, and so I'm not going to go over it again today. What we will go over is the last bullet item shown here, which is the conclusions from discussions on use case statements not covered in problem statement or architecture drafts as presented at IETF 95. And what that refers to is that at the last IETF, I brought up a litany of 21 different items that were statements contained in the use cases draft for which I couldn't exactly see a direct correlation with statements in the problem statement or architecture drafts. And I wanted to be clear that those statements in the use case drafts either were or were not going to be supported by the architecture. And so we didn't have time to discuss them at the last one, but we did discuss them on the list and were able to come to what we considered reasonable conclusions for 17 out of the 21 of them. And that leaves 4 remaining that are still open for discussion. And so I'll briefly review those 17 conclusions that we came to here, keeping in mind that they're not hard and fast decisions. They're the best conclusions we could come to based on the list discussion. And if you have anything else to say about them, please speak up. Next slide, please. So use case draft goals. As before, we provide industry context for the DETNet goals and a yardstick for the functionality of any proposed design. That is to say, we're going to continue looking at the use cases as the architecture evolves and validate that the architecture is still satisfying the use cases. Next slide, please. The draft status, again, what's new this time is that we have the resolution to 17 of the 21 questions. We'll present those briefly. Next slide, please. The future plans, we continue to review the proposed design against the yardstick of these use cases, and as the architecture progresses, we'll expect that it will remain consistent with the use cases. Having said that, there are places such as those we've identified in these items in which the use case draft needs to be updated to say, well, nope, that's not in scope, not going to happen, or to identify places in which the architecture group has to pay more attention to the specific items which are being mentioned in the use case draft. Next slide, please. The use cases, as you recall, come from various different disciplines. I'm not going to go over those. They've been gone over before. The next step that we took in the use case development history was to extract from these use cases common themes, which all resulted in a list of things that needed to be supported by DETNet. And I'm not going to review those either today because we don't have time, but we'll page through them just very briefly, and you're encouraged to have a look at them. Next slide, please. The common themes are handy to keep in mind as you listen to the upcoming architecture presentations to make sure that it seems like nothing is at odds with these. Basically, we're looking at a unified standards-based network, and we're looking to provide AVB style layer 2 quality of service in a layer 3 routed IP routed environment in which all of these different protocols can coexist on the same enterprise class network. Next slide, please. One of the key things that comes out of looking at all the use cases is that there's a lot of scalability that is going to be required. There are DETNet networks that occupy the inside of a machine in which we have many very tight servo loops, for example, in a manufacturing system, which have very short distances but very tight tolerances. But at the same time, we have DETNet networks that are very broadly geographically distributed. For example, the utilities network that can cover an entire nation and connected by many types of links, including radios, microwaves, fiber, all these things. So there is a lot of scalability issues or just considerations, which we want to keep in mind. Same goes for timing. You know, what would seem to be a tight time constraint in one network might be quite different for another, but the important thing is that they be repeatable and bounded. Same with reliability. They're very high reliability and extremely high reliability and everything in between. And so we need to make sure that we can scale to those. Next slide, please. Okay, so now we're going to move on to today's material. For each of the items, I've created a bullet, and for each bullet, it's either put in strike-through text, which means that, nope, it's been decided not to be in scope, or it has a question mark next to it, which means still more discussion, haven't really got something concise for that. There are 4 of those such items, which are summarized at the end. We can consider them if we have time, otherwise they'll go back to the list for future consideration. And if they're in solid text, it means that they're considered to be within scope. Next slide, please. So there are about 4 pages of these statement resolutions in this general form. So the top 2 main ones, the open internet is not supported. That's one of those ones in which we have use cases which say, yeah, wouldn't it be great if we had DETNet quality of service on the open internet, but that's not going to happen in this DETNet piece of work. So that one is scratched out. Linking multiple islands is supported, meaning if you have DETNet sort of networks which are interconnected by some kind of deterministic link, that use case is supported. Providing synchronized time, DETNet requires synchronized time, but we're not going to specify how it's provided. We assume there's other means of doing that. There was the question that came up about whether it's necessary to express an application or a device's requirements for time and accuracy and reliability, whether that was part of DETNet or whether it's part of some external facility. We haven't concluded that. That's our first question mark item. The topic of the role of plug and play in the context of a centrally administered network still is viable. We have use cases in which if a device goes down, we still have to be able to replace that device even though without bringing down the whole network. So we're assuming plug and play still has a role. There was a question about stream startup times and whether they need to be bounded. It was decided that that ability to bring up a system from scratch up to a given level of functionality is a system-wide issue, not necessarily a pure property of how long it takes to start up a given stream. So we decided to leave that open for more discussion, but in general, it seems that that's a system issue and not a specific stream startup issue. But because, obviously, if for some reason there's something that prevents streams from starting up, then that could be a problem. So further discussion there. Link authentication and encryption. Similarly, decided not with the responsibility of DETNet. Presumably some higher link or other layer will take care of that kind of thing. But it is the responsibility of DETNet not to break authentication or encryption. Link aggregation, I actually use this term apparently in a non-standard way, but what I meant was the case in which, for example, you have a high bandwidth video stream that needs to get from one end of the network to the other, and there are multiple paths in the network, but no individual path has enough bandwidth to accommodate that stream. Wouldn't it be great if that single stream could be broken into multiple streams and sent and reassembled at the end? We decided that that is not necessarily going to be a property of DETNet. Will be a nice thing to have, but has to be provided by a higher layer. Latency matching, this is another open question. The application is that between one device and another, there's a path in one direction and a path in the other direction, and there are some applications, notably in utilities, that require those to be matched by providing presumably some buffering in one of the paths to match the other. We're not clear exactly how to address this in DETNet yet, but that's something that could, in principle, be addressed. Traffic segregation was not adequately discussed, but the problem was something that had come up in a context of an AVB LAN, in which if you have many, like thousands of small devices on a LAN and they all wake up after power up and need to discover each other and so on, that there would be some issues with that. For the moment, I'm figuring that that's not as much of an issue for a centrally configured network, but that is subject to further discussion. I see on my chat window, it says Lou Berger question for Ethan. Does this mean I should stop for a moment here?
Yes, this is Lou. I'm happy to see that actually worked. I was wondering if it was going to. So thank you for all of these. It's very good resolutions. I think the providing synchronized time may not be, the way you phrased it is not exactly as I understood the resolution, and it could be I'm wrong. It could be you're wrong. It could be the room disagrees. I thought we had agreed that we wouldn't come up with new mechanisms for synchronized time across subnet layers, but we might coordinate them. So for instance, if we were going from a Ethernet domain running 1588 to an MPLS domain that's also running something equivalent, that we would at the DETNet layer or within the scope of DETNet, we would coordinate the time distribution across those systems. I thought that was our resolution. At least that's how I interpreted it. We have a couple of people coming at the mic, which you may or may not be able to see.
I cannot see.
Hi, John Dowdle, Airbus. Sorry if we've been around this boy before, perhaps I've not been paying enough attention. You talked about link aggregation. So maybe if you have more traffic to deliver than you have available bandwidth on a single path. Obviously, there's been some very good work going on in the multipath TCP group. And I think they were demonstrating a couple of meetings back. Is that something that you have discussed with them about maybe adapting some of their work at all?
I have not heard of that yet, but it sounds like a great idea.
Yeah, they did a very cool demo a couple of meetings ago. Yeah, have a chat with them.
Thank you. Thank you.
Norm Finn, Cisco. Ethan, thank you for mentioning the link aggregation point, that wasn't the best term for it. The traffic segregation, I had a bit of a different view that the multicast MAC addresses to many devices. I don't quite understand what that is. Could you explain a little more?
Unfortunately, I'm not a great expert at this. Balas had a better explanation than I do.
Okay. He gets up, that's great.
So this is here just about the 1 to the 32 ratio between the MAC addresses in IPv4, and if you map this to the MAC address, so this is what is behind that.
Right, got it, okay. Useful, like you're listening to.
I didn't quite get that.
And yeah, you have to use the mic and say your name.
Okay, Norm Finn. Pat didn't quite get that. It's simply that currently in the 802.1 work, every stream requires a unique MAC address VLAN combination for that network. And the usual way for assigning IP multicasts to MAC addresses doesn't guarantee that. There's a 32-to-1 potential, so don't do that.
We should move on just because we're going to run out of time.
Okay, next slide, please. These are the 6-tish comments. I'm not even going to go over them. They're pretty specific. If you're interested, Pascal is the expert on that. But this is what we came up with. Next slide, please. DETNet will stay consistent with 802 TSN. This was a question as to whether that was a hard requirement or whether it was just kind of a general tendency, and the architecture team assures us that the two will not diverge. Therefore, this is something we can rely on. There were a couple of statements in the use cases that referred to very small time values, like 8 nanoseconds or 2 parts per billion. That struck me as being below the threshold of time that we generally deal with in DETNet, and it was clarified that those values indeed need to be supported by hardware or some lower layer, but that we would leave the values in the use case with a disclaimer saying that it would require lower level support, and that's what is reflected in the current draft of the use cases. There was a comment about security allowing for long leases. We agreed that this didn't seem to be necessarily a property of DETNet, but that there shouldn't be anything that would interfere with that. For example, there's not going to be some policy somewhere that says, oh, you know, oh, this lease has been around for too long, we're just going to cancel it, because one person's idea of too long might not be the same as another's. There was a statement about the data plane transport standard being unified among X halls. This came from the radio example. And this simply required clarification as to the definition of that statement, which we agreed was that it means that different flows with diverse DETNet requirements must coexist in the same network and traverse the same nodes without interfering with each other. This is a core property of DETNet, and thus this is explicitly supported. Next slide, please. There were a couple of other topics that came up out of the context of that. One was privacy in the RFC 7258 sense, and the architecture team agreed to address this topic. Another one that came up was support of interconnecting DETNet networks, and as we discussed earlier today, that is explicitly supported by the DETNet Charter, and so the notion of having multiple DETNet networks interconnected by some kind of deterministic link is a supported use case. Next slide. So we're out of time, it looks like, but the last one simply summarizes the ones that have question marks, and if we choose to talk about them now, we can. Otherwise, we can postpone to another to take them to the list or whatever. That's my slide.
All right, well, thank you very much. We don't have a lot of time. If there's like one question, squeeze it in.
Hi, this is Xavi Vilajosana. I want to make you aware that we submitted not that far a draft about the requirements that come from a wind park, so wind farm, and we extract that requirements from experimentation and also analyzing different standards in the field. So I think there are very relevant aspects that we should look at, and we ask if we can consider that draft as well to be studied along with the other use cases.
Yeah. Out of curiosity, so the last speaker was mentioning that they submitted a draft on wind farm requirements. How many people are aware that there's a individual draft on wind farm, the wind farm use case? So a few people. How many think, and you don't have to have read the draft, I'm explicitly not asking that. How many think that adding in a use case of wind farms would be interesting and relevant to the working group? It's about, I think it's about the same number, maybe a little bit. Something's happening with Ethan apparently. Oh, Ethan apparently raised his hands, and we have.
Yeah, I just want to ask a question because it's related to utilities, it's related to power on energy.
Can you lean into the mic just a little bit and then say your name?
That's Patrick Vetterwald.
Thank you.
Just reading at the draft that you wrote, I think that the requirement is already in the document that we have because it's not different in terms of protections, in terms of frequency management, in terms of SCADA interface. So we need to discuss to see if there is differences from what is already in the draft coming from your wind farm use case.
It's actually okay if it has the same requirements. The fact that it's an additional use case that someone in the working group cares about and there's interest in the working group to add it, that should be enough.
So for us, the application, I think it's interesting, and if it matches with your work, maybe some of the requirements can also be mixed. So we are not. Yeah. So we are not posing for a different section if it can match in the other one.
It seems like there's enough support to at least do the work to propose changes to the document. So work with the authors and propose, here are the additions that we would do, and send it to the list and see what the reaction is. It's always easier to judge specific changes than hypothetical ones. Okay, thank you. So now we're going to move on to the terminology discussion. So this is a really important discussion, and it'll help unblock our other work.
All right, so so this is Norman. I put together the kind of summary of the terminology discussion. This is something that we have been going through in the design team quite a bit. And the next slide. So what we really need to do is to agree and finalize. So we are quite far on the agreeing path, but we need to finalize the terminology that we are going to use in this working group. And the what we need to kind of be able to distinguish, following what Norm said in the last IETF, is the what thing, like what is the feature that we need. And I have an example of explicit routes, and then the how we actually achieve that using some existing technology. And as an example for explicit routes is the LSPs. Next slide, please. This is just the I updated this the table that we had the last time. I took one draft away and replaced that with the service model. Then I run through the terms that we have there, and added those that we didn't have last time, and updated some of the existing stuff. So the most of the movement has been on the architecture draft and the data plane alternatives draft. And also the recent publication of the service model added a couple of new terms that are only used in the service model. We can already see that the architecture and data plane are quite getting there already. So they are at least trying to use the same terms. And we actually had the kind of late edits and updates of the document, trying to kind of put some of the terms from the architecture into data plane, and also like put some, we had a difference in different names and the kind of semantics for certain terms. So we moved some of these terms back to the architecture document. So the coverage is pretty okay, but it's not like good enough yet. So there's definitely some work to do here. Okay, next slide. And then like the one place where the kind of differences originate from. So from the architecture document, we have this very simplistic architecture picture about the DETNET system, which has the end system, relay node, and the other end system. And then there's this excellent stack picture. In the data plane draft, we just have the kind of end-to-end system described by the terms that we have in the end-to-end system. And we already see that the some of the things that we have in the data plane draft are taken from the stack figure. And we have some nodes in the network that are not present in the architecture, high-level architecture picture. But the kind of sum of this high-level architecture and the stack is pretty much the equivalent of what we have in a data plane draft, with the kind of exclusion of the edge node. But the still kind of getting there, but not exactly there yet. Okay, next one. So even if we have pretty much the same terms already used in most of the drafts, in some cases still the kind of semantics and the meaning might differ. So again, I will have some examples about those. So there might be quite a good overlap about the meaning and the semantics, but still like they are not exactly the same. So there's always kind of room for misinterpretation and the kind of always question like what exactly this node is going to do and in which cases. So let's go on. The next slide. So the first example, so all my examples are now between the architecture and the data plane, because those are the things that I work most on. So the transit node is probably the thing that is most close in these two documents. So like the overlap is at the level that we can actually remove that from the data plane document that also describes what is the transit node. Next slide. The relay node, again, we can see that the descriptions of this node, they start in the same way, but then on the architecture, it actually goes describing a bit more of the like relay node to incorporate the transport functions. That is pretty much assumed to be in the data plane alternatives document, so it has to have the transport functions. And the architecture document says that what it does is the kind of does the for the seamless redundancy purposes, it does the replication and elimination, which we don't really say directly in the data plane alternatives document. We do refer it, saying like it may provide a services like a service function as DETNET reliability. And later we can see that the DETNET reliability basically is about the packet replication elimination. But like again, which one is the closest? So we need to kind of figure out what is the correct wording for this description of the relay node. Let's go on. Relay edge node again. About the same, but not exactly the same. The key thing is that they both say that they are the proxy functions on the service layer actually. So which is the kind of key thing for these edge nodes are doing. The next one. And okay, so the data plane alternatives talks about the DETNET reliability, which means basically that you are able to split and merge streams and drop the duplicates. DETNET architecture doesn't use exactly the same terms, but it has exactly the same meaning, but it uses like a loss prevention for DETNET reliability. Again, which one we are going to use, we need to decide. But again, okay, next slide. And the service layer. So in the architecture document, it exactly says what it does. So sequencing and the packet elimination part and the replication and the elimination of duplicates. The DETNET data plane draft goes a length into describing all kind of junk, but eventually it is supposed to mean the same, but it doesn't really say that. Okay, next one. Transport layer, again, in architecture, it directly goes to saying what it does. So again, like for the reliability, splitting and merging data plane flows for the replication and elimination purposes. In the data plane draft, we don't really say it, but the kind of assumption is that it's supposed to do the same.
Yeah, a quick one, Norm Finn. This is the first difference, I think, in the ones you showed that can't be very easy to resolve, where they weren't intended really to mean the same thing.
Yep.
And I think this is also fairly easily fixed. I think the data plane alternatives is more correct. So I don't think this should be a big this should be a big deal.
Okay. Yeah. Next slide. So the all right. So the next step really is that we hammer out the terminology. So we nail down what is each term going to be, and the kind of silent consensus has been that we also have been discussing where we should describe this. And my personal opinion, I hope that some other people also share that the architecture document that is anyway going to describe the whole architecture and having the nice high level pictures, that's the place that we will to kind of have all the terms described. And the other documents, we need to see the burden of aligning to that. And now that hopefully, for example, finally get the data plane alternatives document out of the design team into the working group, we can kind of do that in a more open fashion, and also get the input from the rest of the working group.
Norm Finnegan, one last comment on terminology. Lou had asked, do we have the term DETNET defined? And my easy answer to that would be that should be, I believe, the abstract of the architecture draft.
Sounds great. I don't remember asking the question.
I don't remember a lot of things.
Thanks, Norm.
Okay, so this one was basically kind of, I don't have any more slides on this, but this kind was kind of invitation, like all the drafts are out there, and the has been now worked with a fairly small group, and what is really needed now that the kind of broader audience takes a stab on it and have their kind of opinions viewed.
So we have just under 10 minutes scheduled for this discussion. If no one wants to come to the mic, I'd say, oh, Pat wants to go to the mic. Never mind.
If we're open for discussion on specific terms.
Yeah, what I was going to suggest is when there's a lull, just go to the one that you think is the next most important to discuss. And Pat's going to start you. Pat's going to start you off with her most important.
Okay, I lean towards, I'm not sure it's the perfect term or the right term, but I lean towards something about DETNET loss prevention or zero failover, because to me, reliability is very broad. And there's a lot of kinds of reliability out there. And so it doesn't focus on what sort of reliability we're talking about. And the other, the loss prevention does, yeah.
I'm not sure they mean anything different to me. So, but I'm also not sure I care.
Reliability can be how often does your equipment fail, for instance, or it's a lot of different kinds of reliable. It often doesn't mean I won't lose one packet.
Yeah, I listened to Pat and opted for that in the architecture draft. I don't think it makes that much difference, but loss prevention probably has a lot less baggage and will get people to not assume they know what we're talking about, which is probably a good thing.
Yeah, I agree.
So just to gauge the feel of the room, how many folks are comfortable with the term DETNET loss prevention versus reliability? So we have a few. How many object to the use? 0. How many people care? A little more than actually that raised their hand the first time, but not. We'll call it about the same. So we're going to use the term DETNET loss prevention.
Okay, that's fine.
Preference for what we talk about next?
Where do we go next? Yeah. Fiona.
I don't have preference, so, because I'm just fine with all of these.
Okay. Okay, tell us which ones are obvious.
Janos Farkas speaking. Just a question on your last slide, or well, actually moving some of the terms and having the architecture as the home for all the terms. Yep. You had the figure comparison, this very simple figure we have in the architecture. Yes, this one. I guess for some of the, do you plan to move the bottom diagram as well to the?
Good. So yeah, you're not supposed to ask that kind of questions online.
We have to think about what is architecture, what's framework, what's and have to draw the line somewhere. I'm not saying where the line draws, and maybe we'll defer to the authors.
Yep.
To make that call.
Currently, we do have. It's a kind of funny thing because you don't find some of these things what we have in the lower picture in this very complex architecture diagram, but we have all the words somewhere in the architecture document, either in the stack or then on the various pictures. So you kind of find everything in the architecture document.
Yeah. I mean, you could fold the whole data plane alternatives into architecture if you wanted to. I don't think that'd be a great idea. If there's anything in data plane alternatives that might be moved to the architecture, it's probably that diagram, because I think it helps make a difference between the various pieces. And I think the author should discuss that. I think that's something we'd want to take up offline. Yep. But it's definitely worth talking about. I will point out that there's one term that it isn't there now, that had been there, that we took out, which was a transit edge node, I believe. And there's still discussion as to whether we need that. Balázs and I had, and Janos had a great talk about it this afternoon. So, these are not ready for RFC. But I think there's a lot of good work to be done on these, but I think both of them are pretty much ready for adoption, so we can move ahead.
Suvidas, I think thanks, Ioni, for doing that. But I do not have any preference for whether it's loss prevention or reliability. But I believe that if we use loss prevention, we should define what is DETNET loss mean.
Yep. So what's next on your list in the 4 minutes?
For me, I don't have.
I wanted to ask a question. Your examples didn't include talker, source, destination, receiver. Those are resolved?
Yeah,
Okay.
they are no-brainers.
Okay.
Those are easy.
Yeah. They just need to be aligned like a.
Yeah, it was mechanical work that I actually missed one in the current architecture, in the draft 06 architecture. I actually missed one.
Yeah.
Those are nits we've got to fix.
Okay.
But these are the examples that have kind of deeper meaning, and like we spent quite a long time, for example, kind of saying what's the difference between relay and edge node, and now we had the third one, which great discussion. I also would like to hear what was the kind of outcome of that. So,
Right.
But these are like things that we need to hash out.
Taking off my chair hat and putting on my technical hat. This one here was one that I felt pretty, actually, no, never mind. It's been corrected. They both say kind of the same thing.
Yes.
Okay. I don't have a
We
strong
heard you.
preference here. Yeah. Okay. That one's covered. Sorry. Just the words are in different places in the two. Okay.
Yeah. Okay. So
Yeah.
I'm done with this. So
So
I rather kind
I
of.
guess take any.
let's go through 1 through 6 in order then and see what we have left. So transit node, I think you said we're in good shape.
Yeah,
Yep.
the difference is pretty minor.
Relay node, do we have any substantive?
Well, both mean the same. It's just wordsmithing to put
Okay.
that in one place.
I think it's good to, you're the one who convinced me of this term, by the way. So I think, and the way you did it is you described it in sort of IETF terminology,
Mhm.
and that was very helpful to me. So perhaps we should just make sure that we have terminology that covers, works for the IETF as well as from the TSN perspective.
Okay.
So the authors will work that one out. So that's 2 of 6.
Yep.
Now we're on 3 of 6.
These are pretty close. The key thing I think here is that it has the proxy function, which is available in both. So it's for this.
So does it really
interworking
come down
cases.
to whether or not we call it a edge node or relay edge node?
Well, I would just call it an edge node.
And I
One-
guess the
DETNET edge node, yeah, and
microphone, please.
I wasn't-
Microphone. It's not a volume. It's a remote participant issue.
But I'm really loud.
But they still can't hear you from
Yes,
thousands of miles away.
Norm Finn. Yes, I think DETNET edge node is quite sufficient. I don't think we need to throw in 16 words where 12 will do.
Great. That's easy. So we'll move to 4 of 6. We've done that. Oh,
Yeah, we've done that.
Pat, you want to say something?
Well, if you take out relay, then it's any edge node.
No, it's a DETNET edge node.
It's not an end system.
Okay, it's not an end system. Okay.
Just an edge node. It's a DETNET edge node.
Okay, okay.
That is the risk there is that people will confuse these edge nodes, which are in the middle of the network, from end systems.
The reason it was there is that at one point there was a DETNET transit edge node.
Boy, am I glad we got rid of some of those terms. Too many.
And so there was a DETNET relay edge node and a DETNET transit edge node. We got rid of DETNET transit edge node. If it comes back, we'll have to go have relay edge node and transit edge node, perhaps, if it comes back.
Yep.
Hopefully it won't.
and I think we were on service layer.
Yep.
And this seems like mainly wordsmithing. Do you think there's a bigger disconnect here?
Well, from
To
this
me,
semantics
read,
point of view, they are the same.
yes, I sort of read the right as as a general description and the left as a functional description.
Yep.
So
Pretty much.
it's not even necessarily a replace, but a merge.
So we put
Yep.
them
So
together.
go ahead.
Yeah, we had some great talks with Balázs and Janos today. Where we really are starting to think of the service layer as also the relay part of when you talk about a relay node, it's really doing the stitching of transport services. That's a key part of what it does, is it stitches transport services. And as it's doing that, it's deleting packets, looking at serial numbers and so on, and might be deleting packets and stuff. But the key thing is that it stitches various transport level instances of the service together. And I think we will want to capture that going forward. Great.
Yep.
All right, and the last one was transport, and we did that already. So I think you're done, unless you have anything else you want to talk about.
I think we're pretty well in sync.
Great. So it seems to me that the next step is one update of the architecture document based on terminology. One update that captures the terminology discussion in the architecture document.
Yep.
Sound good?
Yeah. Were there any DTL things that needed to be changed?
Well, once you are done.
Authors, you can go work it.
We'll work that out.
Okay.
Great. Thank you.
All right.
All right. So now Norm is going to be up.
Yep.
Sorry. trying to
Norm
get this
Finn,
to work.
we've got the DETNET architecture. Now, in the range of documents that we often get that we always get out of working groups, I'm not sure architecture is always one of them. So something we have to consider, is this a document that we want from this working group? It seems to fit, it seems to be useful. People who ask what is DETNET, this seems to be a useful place to start. And so I think it is useful to us. Go ahead. This is what we're going to cover, the usual stuff. Go ahead. Let's cover it. This slide has essentially unchanged from the last time, from the last meeting. We want to have an architecture that does all these good things. We want, in particular, we want assured maximum latency and extremely low packet loss in a mixed bridged and routed network, taking advantage of the TSN standards without disrupting what we do today in terms of quality of service. And we want to do as little as possible to do that, because we're lazy in a good way. Go ahead. Some objectives and some non-goals. It's particular that we have to understand that the critical streams that we're interested in have essentially fixed bandwidth, and congestion control via feedback or throttling is not an option. I like to repeat that at every meeting. Tunneling through L2 networks to connect TSN domains is certainly not precluded. It is certainly a service that we want, but it's not a specific goal, and it's certainly not the only goal, because often the target applications are too big for a layer 2 network. So making the layer 2 network bigger is not sufficient. Precise time synchronization is typically required, and by some of the proposed queuing mechanisms, the low-level, I should say the low-level queuing mechanisms that are defined so far in IEEE, but it's not a specific DETNET. There seems to be some small disagreement on how much we need to say about time synchronization. I'm in the camp that says, let it alone, let the other groups handle it. But there's some disagreement on that will work out. Next. Okay, the current status. Version 6 is uploaded, was uploaded on 8 July. I list three big changes here. There were a lot of terminology changes that we just talked about to be aligned with the data plane alternatives. The layering is simplified. There were objections that it was looked too much like implementation. Okay, so we simplified that, made it, that also is now closer to data plane alternatives. The packet replication and elimination are now not the central feature of the document, but an example of loss prevention and not the only possible approach. But it's the only approach that has been examined in detail so far. There are two other changes that I should mention, and I've failed miserably to get them into the slide deck. One was that there's a paragraph or two on privacy. It simply points out that because DETNet requires identifying particular flows and it can require establishing state in every hop along the way to ensure that flow gets delivered correctly, that is potentially has some interaction with some of the methods that are being proposed in various groups for privacy protection. So that's something that can't be totally dismissed out of hand. And the second is that the architecture document now brings out the point that a flow at one level, let's say UDP port number, the identification of that flow, sometimes it's very useful to export that individual flow down to be visible at a lower layer. So for example, communication between two routers through a bridged network, instead of everything is just the destination address, MAC address is the other router and the source MAC address is this router, you may want to have different flows going between those two routers to be assigned special, unique to each flow destination multicast MAC addresses so that the bridges can see that these are different flows and treat them differently. So the idea is exporting to a lower layer flow identities at a higher layer is something that may be necessary and useful in the DETNet scheme in order to get the services required by an individual flow at the lowest layers. That's clear in the document. It's not clear in the slides. This slide hasn't changed from last time. The essential aspects of architecture of reservation and enforcement and defense against misbehaving devices. The middle point has changed a little bit because it used to say packet replication and elimination. Now it says loss prevention, of which an example is packet replication and elimination. Not to network coding needs to be investigated. At least network coding needs to be investigated. And if anyone wants to take that up, I encourage them to do so. I think it may be very useful. Next. One size does not fit all. Your application may be interested in only loss prevention. That application may be interested only in maximum latency. So it has to be, we have to be able to pick and choose which features we want. That last is control plane, which we haven't really gotten into. I see a question.
Yeah, can I ask? So Subir, a second. So Norm, I think that's remember your replication is that assumes that there are multiple paths available, correct?
Multiple what?
Multiple paths available.
For some services, the loss prevention. The primary loss prevention scheme that we've talked about so far requires multiple paths.
Right.
If you only need congestion loss and you're not worried about service availability when devices fail, as opposed to the more common cause of packet loss is congestion loss. If you're only interested in deleting congestion loss, a single path is fine.
Correct. So the point I was trying to also understand from you that do you include that retransmission or duplication of the packet in the similar way as replication?
You mean retransmission,
Yes.
like acknowledgement and retransmission?
Yes.
In general, we're not considering that. Those features have been in the internet world since day one.
Right.
We're not considering that because in general, in many of the applications we have, that would result in too much latency.
Yes.
Yeah. Yeah.
Okay. By the time you time out and retransmit, it's too late. You don't need the information anymore. So in general, that's not useful.
This is Pat Thaler with chair hat on. The whole idea of deterministic was deterministic delivery by a certain time. And so retransmission doesn't fit that.
Okay. No, but if it within the time bound, then it basically, is it allowed or not?
So an application could certainly request a DETNet service
Correct.
and then run TCP over it.
Right.
Whatever the DETNet service interface is,
Okay.
which, by the way, may have another IP, may have some interesting transport of its own.
Right.
They could run TCP if they wanted. We don't think it makes any sense, but we're not going to say restrict what applications put on the DETNet service.
Right.
Okay.
But we're not considering that as a prime candidate for a way to to achieve the DETNet service.
Yeah, and that's really important. Is it's in terms of what we talk about, like DETNet layers and DETNet content. TCP is not going to be there.
Right. Okay.
Pascal Hubert, just the wireless angle as usual. Wireless usually include a layer 2 acknowledgement. And when you know exactly when the transmission must occur because you have a scheduled wireless transmission, then you don't need to wait for a timeout. If the packet does not come at the time you expect it, then you can trigger a retry, which can come very rapidly. So it's actually possible on some wireless scheduled technology to have 1 to 3 transmission to represent one hop.
And thank you for mentioning that, Pascal, and that will come up in, I think, the next 1 or 2 slides. I also will mention that. But that's a very good point that there are media, .11 is one example. There are media that provide ACK, NAC retransmission facilities at a very low level, okay? And to what extent the DETNet concepts can make use of that, there's probably some synergy there. There are probably things we can use, okay? If every packet, the obvious problem with it is that there's no guarantee that the retransmission gets through. And so ultimately, what is it's going to be, any time you have something like that, your delivery rate is going to be lowered. Will DETNet improve your delivery rate? Probably. What are the interactions? There's a lot of work to be done there.
Right. So I think that just to add there, a takeaway could be that we are, Subhit, a second. So takeaway is that DETNet layer, we are not talking about a retransmission or ACK.
Correct.
Right? That is the takeaway from here, right? But
Correct.
if the underlying layer can support that without really, I would say, deteriorating the DETNet service, then that will happen, that underlying layer. But I think that's one important point, what you mentioned, that if the underlying layer, say, for example, has an always ACK mechanisms and there is an error in the link, correct? Then it will continuously NAC and retransmit. But what is the tolerance in the DETNet layer that can accommodate that in terms of, okay, is it that if there is a single path?
Well, that winds up being delay variance to the higher layer, and at the levels we're talking about, that can for the applications that are in our use case draft, in the accepted use case draft, the result of that would be packets that are way out of spec in terms of latency, and that's why it's not terribly interesting at this point. For the stuff in the use cases draft, which is what we're using to drive this right now.
Yeah. We're going to need to move this along to keep on schedule.
Greg Erickson, I just want to mention that I think that the scenario, if there is a certain way of detecting degradation, service degradation, that it should be a part of OEM discussion.
Yes, and that would be certainly useful. Thank you. So the next slide. Next slide. Thank you. Which gets us to open. There are 4 open issues, I believe, remaining. Which technology for the stream ID and sequencing should we use? But we have now the DP-Alt, the data plane alternatives drafts to cover that. So that can come out, assuming we get the data plane alternatives adopted. That will be an answered question. We really haven't talked yet about the control plane, and that's fine, but we're going to at some point. Can DetNet help in wireless environments? That's exactly the point that Pascal was bringing up. And also the question about retries and so on. What is the relationship between DetNet and wireless environments? We can play with that. In my opinion, that's tough to go into deeply. I don't want this group to think it's subsuming the work that's being done in 6LoWPAN, in 6-dish, in IP over low, what is it, low capability or something, stupid devices, low power, stupid devices, okay? This isn't an umbrella for all problems. I tend to want to avoid wireless for the most part in this working group. Encoding methods need to be examined versus replication and elimination. There are cases where they may be able to help. There are usually, when you talk about network coding and stuff like that, usually you're taking information for what was originally more than one packet, mushing it together, and sending them out. If those, we're critically interested in latency here. So to what, mushing together successive packets of a single stream is maybe not helpful because I'm sending a packet and I want that to get through, and a while later I'm sending the second packet and I want that to get through. And if I mush them together, if I miss something and I wait for the second one, it's too late, okay? On the other hand, if I'm mushing together data from several different sources that happen to be going to the same place, there might be something there that might help. So it's something to talk about. Next. So the plans are, get this adopted by the working group so we can make some solid movement and get this on track at some point for an RFC. Any other, next slide is just any other questions. Well, I can take the target off of my breast.
Okay, what outstanding actions do you think there are before we should do an adoption poll or formal adoption? Beyond the terminology update we've already discussed.
Yeah, none that I know of. If people have any suggestions, I'd love to hear them.
Okay, so well, looks like we might have one suggestion.
Hi, Tim Shone. So I like what I'm seeing so far and what I've read. I think to me, it seems clearly something we should be building on and taking into the working group to take further. I think you did raise one interesting point about what's in scope in terms of wireless. That can obviously be a challenging environment, and some of the LPWAN type environments can be very challenging as well. So yeah, it certainly needs to be a big health warning on those types of scenarios.
Yeah, I don't expect us to spend a lot of time on wireless here in this group. Okay, so we've already polled the room enough that we're not going to poll the room again. We'll wait for the update, and then we'll do the formal poll on the list. And we certainly expect adoption. If you have any concerns, we would appreciate you to bring them up earlier rather than later. No reason to wait for the adoption poll. If you have a concern, bring it up now. And don't worry, it still can be considered a blocking issue for adoption if you think it's that level of importance. So we're going to move on now to the DETNet data plane document that's going out of the design team.
All right, again, so just a brief update what we have been doing the past 3 months. So the next slide, next one. So things are still able to change. So as you know, next one. The glorious design team and a couple of activists. So I tried to make my best not take any people in addition to design team, but somehow a couple of guys managed to sneak in, and I'm very thankful for their input. Yeah. Anyway, okay, next slide. Next one. Thank you.
Oh.
Okay. So what actually has happened since the 0.0 version? So we did quite a bit of rewrite in many places as usual, but if you take a diff and if you go to GitHub and check what we've done, we actually changed a lot of stuff. Each of these is service layer and transport layer technology alternatives. We actually finally added the summaries kind of describing what is so cool in those and why they fit the purpose. Then we actually tried to illustrate the data plane, how it would work on top of, we just tried to kind of plug it on top of the multi-segment pseudowires reference model and see how it actually fits in there with all these different nodes and service layers and transport layers and whatsoever. We had, we are still having in the data plane document the separation about the service layer and transport layer. Why it's mentioned here that at certain point the architecture draft wasn't so enthusiastic about us having this separation, so this kind of reminder from that time. Nowadays you can find this service layer and transport layer in a way from the stack picture that we have in the architecture document. Next slide. The alternatives for the data plane, they have pretty much stabilized now. So these are based on the input. So kind of we had more when we started, but then the kind of basic laziness of people who put what where. So on the service layer, we have pseudowires, RTP and CRE at the moment, and kind of the UDP is assumed to be part of the RTP. Transport layer, there's an IP descriptions, then there's a bunch of MPLS and 2 flavors of beer, so the basic beer and the transport engineering part of the beer. The criteria that we use to kind of evaluate all of these alternatives, so it's almost stabilized. So we took away the time synchronization part because it was really confusing. Last time I couldn't even explain it myself, so we just took it away. If someone wants to have the kind of time synchronization part of the data plane, we kind of encourage you to look into OEM, what it has to provide in that space. Then there's a couple of things that I was thinking about, like we have the class of service and quality of service also, not only the transport layer, but also on the service layer. So we need to kind of, I'm not kind of confident yet whether we actually need to have that also on the service layer. We have some text that is not necessarily a good text about that, so that might be a subject to removal. Next slide. The kind of major discussion points, so we did spend quite a time about the service model, and we will have a presentation later today that goes into details about the discussions what we had on the service model. Currently, in the last version, I took most of the service model discussions away, mostly because it's just as such it didn't fit into the alternatives document yet, and the one of the bigger things was that the terminology was not kind of aligned between the service model document and what we have in architecture and the database alternatives. Again, these things are possible going to change, I don't know. depends how this service model discussion goes on. There's a good stuff in that service model discussion, but it's not really referenced in the current data plane document. Okay, we had a bunch of the terminology discussion, and we also already solved the reliability thing mostly. We still need to kind of put some concrete wording around that and make sure that the architecture document and the data plane alternatives are completely aligned, because bunch of this loss prevention is divided in this criteria 5 that describes it. Is divided between service and transport layer, and that distinction and division has to be made more clear. It's there in the document, but it still needs a bit more work. Next slide. Okay, you should be aware of this RFC 5254 architecture reference model. Let's go on. And okay, so if we plug it, use the same reference model, what if we put the kind of native DETNET on top of it? So we have the SPEs, end-to-end DETNET service, and then we have the kind of end devices, end systems that actually are able to talk whatever we have in a DETNET transport and service layers. So you can think about the DETNET service as a transport, for example, RTP over UDP IP, or it could be even pseudo-virus. Okay, next slide. Then what if we have the kind of existing TSN end system that don't know anything about DETNET? So how you would transport that over the DETNET network? And this would be kind of a very good example how you would like a transport your layer 2 TSN over the pseudo wire transport network and then convert it back to the kind of native TSN system on the other end. Next slide. And then of course the case that you have the kind of non-DETNET aware end system that wants to talk, that talks over the DETNET system to a native DETNET aware end system, and you need to do the kind of the proxy function on the edge node to make these guys to talk together. So you don't need to make any changes on the legacy or the existing TSN end system. You do the magic on the edge node, whatever is going to be your DETNET transport on in between. And the last one, next slide. Okay, so you have seen this picture. So basically, this is the previous picture on the how we described that in a higher level in the alternatives, so that we have the end systems that are either DETNET aware or not DETNET unaware, and then you have the edge node that does the service proxy function. We have the kind of plain transport node, transit node, and relay node, and the and between this system you can have a direct link to our sub networks. Okay, the next slide. So there's still a bit kind of bigger things to do. The terminologies, of course, we've spent already time on it. So except one more revision of this document aligning the terms. And as I said earlier, that the kind of be more concrete and more precise on how the division for the loss prevention happens between the transport and service layers. So which functions really are done on which layer. So the kind of sequencing, duplicate elimination, or the kind of packet replication and merging of flows and so on. And then of course the kind of the final outcome of the document. So currently there is a concluding summary in the document that doesn't necessarily kind of reflect the views of all the design team members. So it was put together by a couple of guys only. So we need to run that through the rest of the design team members so that they actually agree what we are saying there. currently is pretty biased by a couple of outcomes. And we also need to do the final check that it actually reflects all the latest changes that we had on the summaries in the for each technology. Next slide. So the current conclusion in the data plane alternatives document, it kind of leans towards that the pseudo wire over MPLS LSPs is one, or pseudo wires over IPPSN is also one possible solution, or then the RTP over IP. And there's a blah, 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 blah text pretty much directly taken from the draft. If you go to the next slide. So the kind of discussion that we need to have soon is like the once we have the kind of document ready shape, but be prepared for this discussion. So we actually need to go and select the data plane solution that we start working on. So we could select one solution or select two solutions, and then the select three or more doesn't reflect my opinion, but it reflects our chair's opinion that we are limited to maximum 2 options to work on, which is okay, because we also need to complete the work here. So anyway, so you need to prepare for this discussion and also kind of, so this is the current set what we have there as a solution. It might be that there will be more options that we will have to kind of run the selection through. Next slide. So the next steps from the draft point of view, of course, we would like that to become a working group document and kind of complete the work in a working group. So from the design team point of view, so we spin one more revision of this, which is going to be simple, mostly on the terminology part. And then we are going to use this as a hammer for the selecting the data plane solution.
Okay, so you heard it. The plan is to do one more update on the document based on terminology, and then the authors believe it will be ready for working group adoption. This document we haven't talked to the room about. So how many have read the document? That's a pretty good number.
Sure.
What's that?
I'm not sure whether I have read the whole document.
How many believe it is a good foundation for our work? So slightly less, but still a good number. Does anyone see a problem with the document other than alignment of terminology that we've discussed?
And the kind of not complete the summary.
I wasn't even going to ask that. Yeah. So, but either way, how many see any problems other than the things we've carved out? So we have no one there. So that seems like pretty good support of the room. Obviously, we'll do the update and then take it to the list.
Yeah, and depending how fast we can proceed, I really would like to do that like well before next IETF.
Oh, you're right. I should have asked that question. Let me phrase it this way. Well, how long until you're ready?
So when Norm is ready, then I'm ready.
Norm, how long do you think for your document? And I'll repeat because Norm doesn't like getting up for the mic.
Should have it by Friday.
So Norm says he'll have the architecture update on Friday. I'm looking to Yoni for how long?
Well, and during the following week.
Okay, so maybe another week after that. So if we're looking for adoption poll in the next couple of weeks. So one of the things we do before adoption polls are IPR polls. We will do, I can't remember if we did an IPR poll yet for the architecture, but either way, we'll either, I'll we'll either start for one or both documents in parallel, because that we don't have to wait for the update.
All right, I'm done.
Thank you. Okay, so we're on to the service model. We're actually 15 minutes ahead of schedule.
Hi, my name is Balázs Varga, and I would like to present to you what we have about the service model draft. During the discussion in the architecture and the data plane documents, we find out that it would be great to have something like a service model description. And also in the last IETF, we have started to discuss whether DETNET service starts and finish and so on. And we decided to have a written form of the results of our discussion in order to share with the group and being able to collect the feedbacks for this service model stuff. So next, please. This is what I will present about what is the target of this draft, what is the current content, and what next steps we envision for it. And next, please. So it is about to describe the service model for scenarios, and it is really about to define reference points, service components, and some naming for the service model. We have 4 sections with technical content inside that draft, and the first one is about the end system, which are connected to the DETNET domain, the DETNET network, and the conclusion of our discussion. We have a section about the service model itself, which is dealing with the reference point and service components. We have a dedicated section for the service instance inside a DETNET node, which is in order to provide the DETNET functionalities for the data flows. And it was several times during our discussion that we have made drawings about networks with multiple technologies. So how to make DETNET transport over such multi-technology domain and what issues arise there. This is the last section which is dealing with. Next, please. So regarding the end system, the applications which are requiring time and loss sensitive transport, they reside on the end system. And between those applications, there is a data flow. This is what we are calling the application flow or app flow. This is practically the native data stream between the 2 applications. And we have distinguished during our discussion 2 types of end system. One is a DETNET aware end system, and one is a DETNET unaware end system. A good example for the DETNET unaware end system is a TSN end system, which is just originating this native data flow, and it is connected to a edge node via a native attachment circuit. A DETNET aware end system is sharing the forwarding paradigm of the DETNET network. So it is practically the part of that DETNET network, and it is connected via DETNET attachment circuit to a relay node of the DETNET domain. Next, please. This is a drawing that we have used for the service model discussions, where we have 2 domains and we have 2 endpoints connected, 2 end system connected to these 2 domains. Here we have defined 2 reference points. One is application flow endpoint, which is an internal reference point of inside the end system. The other reference point is a DETNET UNI, which is a UNI interface of an edge node of a given DETNET domain or technology domain. We have distinguished 2 types of services between these reference points. One is the end-to-end service, which is between the application flow endpoints. And the other service that we have defined is a DETNet service, which is practically between the DETNet UNIs. And it is practically able to connect networking islands. And it was already mentioned during the architecture presentation that we have not yet focused on the control plane. And we think that it will be important to have also some components defined for the service. And for that purposes, two types of components were defined. This is what you can see in the bottom part of the figure. It is a DET link component, which means that the end system is connected via a direct link to a domain, or it is a link between two domains. And the DET network component, which is practically the network part between two DETNet UNIs. Next, please. A section is dealing just with the service instances, which are doing the forwarding inside a DETNet node. In order to work properly, DETNet functions need two local attributes, which is the flow ID and the sequence number. And the attachment circuits are connected directly to the service instances, and the service instances are configured to implement the flow-specific routing or bridging functionality, depending on what is the requirement of the end system, whether it needs layer 2 or layer 3 connectivity via the DETNet network. This service instance is dedicated for a DETNet flow. This is the assumption here. And the service instances are interconnected via PSN tunnels. The different versions are there in the data plane document. Of course, if you have multiple DETNet flows, they may or may not share the service instance. Of course, if they are sharing the service instance, then you need appropriate flow table or forwarding table entries in the service instances. Currently, it is out of scope for scenarios where you intend to use the same service instance for regular traffic and DETNet flows. But we have an annex part in this draft where there are some highlights about those scenarios. So next, please. The last technical section in this service model draft is dealing with the scenario where you have multiple technology domain and your DETNet flows are transported over that. So these technology domains practically means IP routing, MPLS label switching, or Ethernet bridging. In order to being able to recognize and forward properly and use the DETNet functions on nodes inside the domain, you need the domain technology specific flow ID. This is how the nodes can recognize the flows and behave properly. So that means that for each of these forwarding paradigm, you need proper setting of the flow ID. And that can be created by a domain specific function, or at the edge node, you can do it also based on the original flow ID of the application flow. And of course, this flow ID must be unique inside your domain. And this is needed because, of course, the original flow IDs will travel with the packet, but your domain internal nodes might not have the function to recognize those flows IDs. So this is why you have to add this additional flow ID at the edge of a technology domain. You can treat it also like a flow ID stack. So depending on the domain you are crossing, you have to have the technology specific flow ID. And as you can see here as a note also that currently we have focused just on the flow ID, but there is also a sequence number parameter which should be considered also. Next slide, please. In the draft, there are two examples for this flow ID mapping. One is related if two IP endpoints are connected over an Ethernet domain, where we have a IP end system and an IP router. And on the next slide, you can see that we have also an example for MPLS technology domains where the MPLS nodes are interconnected over Ethernet domain providing TSN service. So next, please. And once more. Next, please. Okay, so this is what is the content currently in the service model draft. We have already discussed today about terminology. So this is also something have to be in line with the architecture and the data plane document, the terminology inside the service model. And we have in written form this service model related topics in order to have further discussion on the mailing list and also on side meetings. So these are the plans for the future. Comments, questions?
I have one as contributor.
Yeah.
It's Lou. I think there's a quite a bit of work that's been done in the pseudo-wire area, looking at service models that we could probably benefit from stealing. And I'm not saying you have to steal all the terminology, but looking at the figures and looking for some of the concepts, we could reuse those. We reuse some of them in the data plane document. I think we could reuse some here.
Yeah, absolutely. Just because of the deadline, we were very close when we
absolutely
have finished.
No, it's a great start. It's a great start.
Yeah,
but I think there's an opportunity to sort of run faster by leveraging the other work.
Yeah, adapting.
Yeah.
Okay.
Nothing wrong with it.
Yeah.
Thank you.
Jouni, quick question. So what is your actual plans on the aligning terminology? Because at least the latest version of the draft kind of introduced a bunch of new terms that are very specific to your current draft.
Yeah, I think regarding the service, there are some terminologies that we have not used in the data plane or in the architecture draft. So regarding those terminology, I think the plan is to define it first, and then let's discuss whether the group is satisfied with that terminology in order to avoid the situation that we are starting to use it and then later on we have to change it because of some other drafts.
One other comment to think about is how we deal with devices that on the same interface support DETNET and non-DETNET traffic, because we certainly have to worry about that, and we need to cover that in our work here. We don't necessarily have to include it in the service model and service interface. It's a logical thing. We're not going to specify how it works in a node, but we want to make sure that that's covered across the board.
Yeah, absolutely. I also think that regarding the service instances, whether they are dedicated or not to DETNET, that is also something related to that.
Sure, I'm not necessarily comfortable. I'm not so comfortable with defining an internal interface for an implementation. That's not something we typically do here. So, you know, it's okay to have a conceptual model, but we should be careful to say that this is conceptual. We're not expecting a node to be required to implement it in a particular way. They certainly have to implement the behavior on the wire a particular way, but how they achieve that behavior on the wire is a little bit of their business.
Yep.
I confused Norm, I can tell.
Yeah, Norm Finn. I thought we were at the lower levels, the interaction between the DETNet stuff and the best effort, the other stuff. I shouldn't say best effort because some of it's not best effort.
Yeah, DiffServ.
The other stuff is, I think, up to the subnet stuff. It's up to the lower levels that are doing that stuff.
It has to fit into our architecture, our service models. We have to talk about coexistence, how we achieve that. We just need to cover it. And yeah, we certainly don't expect to have a DETNet layer queuing, which is orthogonal or on top of interface link layer queuing.
Greg Mirsky Erickson. Actually, I was thinking you saying that we don't care how it's implemented, so we don't define APIs, but as long as their behavior on a wire is consistent. So I think that in that case, we are talking about their DETNet domain that can support the DETNet service, but within the domain, there should be some certain consistency. So basically,
sure, there's consistency in the service. There's not, but if I go to vendor A and then go to vendor B, I would expect that they would each provide compatible, conformant DETNet service. But how they choose to implement it internally is their business.
Well, if we want these domains to interoperate,
that's wire format. And that's behavior on the wire. So yes, that certainly has to be there. But whether they have an internal service, 5 internal service interfaces or 1, that's their business.
Okay, then there will be certain gateway which basically interact on a control plane level. Because DETNet will have certain control plane. Not of its own, but the control plane which instantiate their data plane state.
I think we're in agreement that external interfaces that we want to interoperate need to be standardized. I think that's really what you just said, right?
Yep.
Okay, I think we're all in agreement. Okay, thank you.
Okay.
So we're now on to the last scheduled presentation.
No pressure, you're just standing between us and dinner.
Hi everyone, this is Yiyong from Huawei. I'm going to present the DETNet flow information model draft. This draft is mainly focused on the description of the DETNet flow and how to use it. Next, please. And next. So first of all, what is a DETNet flow? Based on the charter, the DETNet flow is a sequence of packets to which the DETNet service is applied to. So which means the DETNet flow is different from the best effort flow, and it receives the bounded delay service. So the DETNet flow may have some features. First, it does not change rapidly, and DETNet flow only sends limited traffic from the source. And also the flow can be synchronous or asynchronous. So the question is how to describe a DETNet flow. Define a flow model may be a good approach, as the modeling approach is quite scalable and reusable. Next, please. Next. So why we need an information model? From IFC 3444, information models are used to model manager objects at the conceptual level, which is independent of any specific protocol used to transport the data. And also the information models focus on relationships between managed objects. So in my opinion, we define kind of flow information model with all the kind of informations that can be mapped into different data models. And each one can be used by different network functions or network entities. So data models are defined at a lower level compared to the information models, and they are intended for implementers and include implementation and the protocol-specific construct. Data models are often represented in a formal data definition language that are specific to management protocols. Next, please. So what kind of information should be included in the flow model? In this draft, we try to define some common concepts of a DETnet flow with all the information that can be used by different network functions or entities. For example, we try to define information can be used for flow identifying and also information for data plan configuration, resource reservation, control protocols, and also YARN models. Next, please. First, the flow model should contain information for flow identifier. Flow identifying is the first step of DETnet service provisioning. At first, we need to recognize the DETnet flow and then use the reserved resource to serve the flow. So here we can do that by the traditional way, such as the source desk, IP address, MAC address, and also we can differentiate the DETnet flow by user plus application. Next, please. So second, the flow model should contain information such as traffic description. In order to reserve proper amount of resource for DETnet flow, we need information of the traffic description. So here the question is bandwidth reservation enough? My answer is maybe not. So here we define kind of burst parameter to describe the traffic duration of the DETnet flow, and also we define the max number of frames and the max frame size within the burst. So basically, the more description or more information about the traffic description, the better delay bound we can provide. Next, please. So finally, the flow model should also contain information such as flow statistics, such as delay and loss information are very important for the OAM system and the control plane. Next, please. So next, I will try to give some examples to show that how we can use the flow model. Next, please. So first, the service model. As mentioned on the service model draft, there are application flow and DETnet flow, and the flow attributes defined on the flow model can be mapped from up layer to lower layer. Next, please. And also the control plan. The flow information is needed by control plans such as the PCE, southbound interface, and northbound interface. For example, the PCE may need the delay information defined on the flow model to do the path computing. Next, please. And the data plan. The traffic description information can be mapped to the data plan configuration. So here we take a TSN time-aware shaper, for example, as the data plan technique. We can map the traffic description information defined on the flow model to the control list in the TAS. Next, please. So next. So the current status of this draft is only the initial version. So we welcome more contributors and authors. We need more information, and we will try to make sure that we include all the needed information, and we want to be clear that how the information model can be used. I think that's it. Thank you. By the way, we're gonna have a demo on Thursday night to show that how we can map the information model to the data plan. Yeah. Thank you.
You said a demo?
Yes, in the bits and bytes session.
So is this mapping an information model to a data model? Or when you said to the data plane, what do you mean?
I think most of them, because for the demo, we cannot bring all the devices here. So the data plane is all simulation. But we try to show that we can map the information model to the data model.
And then from the data model to an actual piece of hardware.
Yes, yes.
And you have a simulated piece of hardware.
Yes.
Oh, very interesting. Feel free to send the details on what you're doing to the list or pointer to it.
Sure. I will do that.
Yeah, not a sales pitch though.
Yeah.
Thank you.
On the information model, where does information? What I don't see in the model, and I haven't read the draft, unfortunately. I don't see in the model where one puts information on what service one needs for the flow. I mean, it said the bandwidth and stuff, but it didn't say like I need this latency or less. You know, the maximum. latency I can tolerate for the flow, or that this flow I want to have the replication for, or I don't care about replication. That is that something that you're planning to put in the information model?
In my opinion, I think, as you mentioned, the latency requirement, something like that, that may be the service attributes. And so we try to map the service attributes to a network parameters. So I think maybe in the flow model, we can include some delay information, but maybe the delay requirements, as you mentioned, for the service.
Tianchen, you said on slide 2 or 3 something about there being limited traffic. Does that mean a limited number of flows or a limited rate, or what do you mean?
Suppose, because if there is no constraint on the traffic you send from source, I believe no guarantee can be made.
Okay, but there's no limit on what you can request if the network will carry it. That's
think
an important distinction, I think.
Yeah, I think what he's meaning there is that it's limited to fit within the bandwidth that you spec. So when you look at page 8, you commit to that this is the traffic I'm going to send, and then you don't send more traffic than you specified there.
Fair enough. Now I have some high bandwidth applications in mind, hence the question. The other one was you're mentioning MAC addresses and IP addresses. So for a given reservation or whatever you want to call it, are the MAC addresses and IP addresses allowed to change over time, or would you have to re-reserve or recommit it if those were to change?
I think right now we suppose everything is user specific, so we only recognize the user by its MAC address.
Okay. I mean, that's one of the things that might come in when you start discussing privacy, where devices might change MAC addresses and IP addresses over time, for example, but still want the service.
Okay, thank you very much. So we had allowed for a little more feedback on data plane. If you have comments on data plane, particularly if you don't see your favorite one listed, please let us know. Send it to the list. And with that, thank you very much for a very helpful meeting. And go enjoy dinner.
Yeah.
Yeah, so 15 minutes, half an hour.
15, okay.
Thank you.
Hey. Hi, are you?
Haha, you're awesome. Thank you. Yep. Good job.
Yeah, I think that there seem to be a lot of people who had a delay getting here. I thought the break wasn't very long.